Hey guys, this is Professor Janacek, and I want to go over another example where we get to work with the fundamental theorem of calculus. Recall that the fundamental theorem of calculus starts with the definite integral from a to b of f of x dx, and then what we end up doing is we determine the antiderivative of f, lowercase f, call this uppercase f, and then we evaluate it just at the endpoints at a and b, and then take the difference of those. One use of this, if you recall, one use of the definite integral was to find the area under a curve. Very specifically, this is the area between the function f of x and the x-axis. So let's take a look here at example 4. We're going to integrate from -1 to +2 of 6x times x plus 1 times x minus 2 dx. If we look at what the graph of that looks like, letting y equal to 6x times x plus 1 plus times x minus 2, you'll notice it has intercepts at 0, -1, and +2. And then, of course, we have our curve. This is a cubic. And the area between my function and the x-axis, you can see I have shaded in. So let's go ahead and determine what that area is using our fundamental theorem of calculus. To begin with, I do think it'll be easier if we go ahead and multiply this out. So I'm going to take this integrand here, multiply, distribute, combine like terms, and let's see, we end up with 6x cubed minus 6x squared minus 12x dx. And all we have to do now is find the antiderivative. Remember, it can be any antiderivative of our integrand. So that would be, let's see, add 1 to the exponent, divide by that, reduce. We end up with 3x to the 4th over 4. Oh, nope, it gets reduced. That's going to be over 2. Minus 2x, minus 2x cubed minus 6x squared. And then for that arbitrary constant c, I'm going to choose 0. But now we need to evaluate this from -1 to 2. So let's see, that's 3. Evaluate the x's as 2. Notice I put that, when I've evaluated a 2. Notice I put all of that in parentheses, and then a minus sign, and then another set of parentheses. Now I'm going to evaluate at the lower limit of -1. Again, just take your time with this. It's really not difficult, but we can easily make mistakes. Just with the positives and negatives alone could cause major issues. So again, evaluated at the upper limit minus evaluated at the lower limit. If we simplify all this, there are a number of ways of going through this arithmetic. And by the way, I have, this is supposed to be a 4 there. So that gives us 16 minus no, that's not right. That's not right. Hold on, what am I thinking? This is 8 times 3, that's 24, minus 8 times 2 is 16, minus 6 times 4 is 24. There we go. Minus, and the second one, ooh, just dealing with some negatives in there. It's going to be positive 3/2 plus 2 minus 6. So let's see, we end up with getting a common denominator, negative 27 over 2. Negative 27 over 2, and yeah, we can leave it as an improper fraction, that's fine. But this is supposed to be an area, and it's a negative area. Does that make sense? Well, if we look at what's going on over here, you'll notice that from negative 1 to 0, this is a positive. However, from 0 to positive 2, oops, this is a negative. From negative 1 to 0, it's above the x-axis, so it makes it positive. From 0 to 2, it's below the x-axis, and it's going to be negative. And you'll notice the negative portion is larger than the positive portion. That's why we end up with a negative for our area. Now, if we wanted to look at the net area means we want to treat them all as positive values. So the first thing we do, notice I would have to look at this graph. I would have to see this in order to do the net area. You must sketch the graph of these before you can take a look at the net area. I noticed that I would have to break it up. I would have to find the net area of the positive piece and then the net area of the negative piece. So we'll go ahead and just integrate from negative 1 to 0 and then from 0 to 2, which is what I've done here. From negative 1 to 0, and then from 0 to 2. Now you could go ahead and complete those integrations, not too difficultly, fairly straightforward. Again, just take your time. I would start off the way we had here, multiply it out, find the antiderivative, and then of course evaluate the antiderivative. First from negative 1 to 0. Again, that's evaluating it at 0 and then subtracting off the evaluation at negative 1, and then evaluate it from 0 to 2 for the second bit. Again, that's evaluating it at 2 and then subtracting from that the evaluation at 0. What you end up with, after doing all of that fun stuff, you should get 5/2, and for this first one, actually let's just write this down, the integral from negative 1 to 0 of 6x, x plus times x plus 1 times x minus 2 dx should be 5/2. And the integral from negative 1 to 0 of 6x times x plus, from 0 to 2 of this should be a negative 16. However, if we're looking for the net area, we want the absolute value of these summed. So what we're really looking at is 5/2 plus 16. Getting a common denominator, looks like we end up with 37 over 2. So the area, and sometimes we'll say area under the curve, is negative 72. I'm sorry, negative 27 over 2. However, the net area is 37 over 2. Notice the net area will always be a positive value. Well, there you go. Enjoy.